All right, so welcome to our lab number 8. Do you suffer from hydrophobia? What's going on? So it is also the myth of the universal solvent. We've been talking about it. It's really been the central theme of our whole term. Every celebration has talked about this. And it is because water is one of the elementals, because it is so much of this planet. So water is about 71% of the planet is water, depending on what website you check. The thing that's really cool, the number is the same as in the human body. It makes you really ponder that. So we are about 71% water. And which part of your body is the most water? Brain, heart, muscles, kidneys? Kidneys would be a good guess. And this is a picture I promised Damon I would have on here. So this is also the purpose of this presentation is you guys need to be picking innovation. So the next 2 weeks term, we only have 2 weeks left. We have to do class presentations. So innovation, some of you have written about something, a short, brief summary from either the plastics lab or clean air innovation. This is one using biomimicry. So hyaluronic acid is what's in the slime of the slug. You also get to draw slugs or snails on the lab. It's part of the post lab. Anyway, the slime is the same thing that is in your knee joints, as well as what makes a baby's face always so soft and supple and perfect. And so these are from High Price Spa somewhere in Asia, and they let the snails just climb all over, slime all over their face, and apparently it is amazing. So if you want to do your presentation on this and do the presentation with snails, slugs on your face as you're doing it, that would definitely get you some extra credit points. Nobody's ever taken me up on it, even though people have joked that they would. So here you go, because it's a post-lab question. Interestingly, bones have more water than fat, and they always tell us the myth, when you're losing fat, you're really losing water weight, right? That's one of those things like in the workout world. Our liver, 86% water, more than blood. How can that be? But the correct answer is your eyes. Your eyes are actually 95% water. And looking still for innovations, there's some really cool innovations for blindness and stuff. So like back in Star Trek, they had the idea, and also for hearing aids and stuff, there's some really cool things you could look into. So back to water in this lab, water is the most ordinary molecule of life and the most extraordinary. We kind of take it for granted. It is the only substance that's found in all 3 states of matter naturally, so solid, liquid, and gas, in all of our lives. And we are like water. We're like the individual molecules themselves are so simple, but yet working all together, we become a force to reckon with. And so, like the snowmen. All right, what's so special about water? Again, really the central theme of the whole term. It is so simple. Just 2 hydrogens covalently linked to an oxygen, giving it this perfect 104.5 degree bent shape. And because of the hydrogen and oxygen, the oxygen's electronegativity greed, it is pulling. And so it is very polar, just like the polar bear. So that polarity is key. So what is polarity? Well, so there's a polar bear behind there, but there's the oxygen pulling. It is magnetism. And so, as you've heard me say many times, we're on that verge of magnetism. There is some kind of healing technique, apparently like Lourdes in France. So the magic of going there and being healed by the water. It is over hematite, I believe, is the deposit actually under that spring. And so it has magnetized the water. And so it does have a healing effect. And so they are actually working on figuring out how to magnetize water in a specific way to help heal different illnesses and stuff. So yeah, something pretty cool. And so we get that hydrogen bond between the positivity of the hydrogen to the negativity. So the dipole is, because it's not a true positive negative, but it's an area of positivity. And because of that, water is not the universal solvent. A solvent is the part of the solution doing the dissolving. The other part is, and they all say in unison, the solutes. And because water is so polar, that solute has to also be polar or ionic. It has to have a positive negative, or else the water is not going to be interested in it. So water is not the universal solvent, as we have proven very well in this day and age. Plastic is hydrocarbons. Plastic, look at all those straws in his boat. Oh my gosh, I never saw it before. So what determines solubility? Polar versus non-polar. And that little thing I told you, like, likes, like. Yeah, polar likes polar, non-polar likes non-polar. The two don't mix unless, well, we talked about hydrophobic. So hydrophobic, another possible topic for your innovation or to look for just your one page on this. There are these hydrophobic surfaces. So this is a picture of a leaf. The leaf is not a hydrophobic surface. It's actually little microscopic hairs that keep the water droplet. And that's surface tension, why the water droplet is always the circle like that. And yeah, so this is the slow-mo, guys. We'll see if it works. It's not going to work again. But the slow-mo, guys, you can Google the video, but it is this hydrophobic surfaces that have been created. So they have a camera that takes a picture in slow motion. So you see the idea here. But that would be a really cool topic. And so making these hydrophobic surfaces that then have different uses. I mean, from anything as simple as coating our goggles or our cars so our cars stay beautiful, to other uses that I'll get to in a moment. So hydrophilic versus hydrophobic, again, the central point of the term. So hydrophilic is water loving. You see lots of nitrogens, oxygens, things that are really polar. And hydrophobic is non-polar, water fearing. So things that are mostly carbons, the hydrocarbons. So you might see an oxygen, but there's not enough oxygens for how many carbons. And so we're going to play this game. It's on your lab a little bit. So is it hydrophobic, amphiphilic, or amphiphilic? Yeah, I don't know. There's like so many different names for this, or hydrophilic. So this one, most of these are hydrophobic. So 1, 3, and 4 are hydrophobic. There's just too many carbons. And like number 4, there's not even a polarity anywhere. So there's not enough oxygen. So on number 1, that's cholesterol. It does not mix. That's the whole reason why cholesterol creates clots in our body, because it's hydrophobic. And cholesterol is absolutely essential in our body. Number 2 is actually amphiphilic or amphiphilic, however you want to say it. So on the left side of the molecule, you have negatives and positives. You have oxygens and nitrogen. You have pooling. But in that upper right-hand corner, it's C16H33. And so that means a long carbon chain. And so that part is, so it's hydrophobic and hydrophilic, which means it likes all things. And so it's called an emulsifier. It will mix. It will be what helps to keep things mixed together. So we have those in our body, our cell membranes are amphiphilic. So they keep things in and out by how it's arranged. They love everything. Another way I've seen it written, and this is my favorite word these days, is amphipathic. Again, these are new words that have just shown up. They were not in any of the traditional biochem books. So it's like empathic. So humans are empaths, right? We feel for other people. So amphipathic is that you like both water and land. And so on this one, most of them are the empathic because they have the hydrophobic. So you see the long carbon chain. So even on number 1, the CH2s have 13. So there's long carbon chains, but you have a polarity. On number 3, that's also amphiphilic. So 1 and 3, however you want to say the word, right? So C10H21, that is a lot of carbons, hydrophobic, but those little hexagons, very flattened hexagons that frogs sat on them, is there's lots of oxygens there. So that part likes the water. And same with number 4. So 1, 3, and 4, in this case, love both polar and non-polar, and so allow it to mix. They're emulsifiers. So we have the long carbon chains, And we also have the phosphate area. On number 2, that is completely hydrophilic. There's an oxygen at every corner. Those corners are carbons. And so it loves water. It is not going to mix with a hydrocarbon. All right, a question on your lab about that, but it's good review. So water everywhere and not a drop to drink. Every organism on this planet depends on water to survive. We as humans are really good at wasting it and polluting it. Isn't it wonderful to have free will? So how much of the Earth's surface is suitable for drinking? Well, not much. Most of it is salt water, which we can't drink, but we're figuring out ways to be able to. So it is only 1%, but even more, how much of it is safe drinking water? So yeah, it's changing. We are making the change. We are bringing safe drinking water to different places, and that's what it is about. So we all know what the problem is. It's what can we do so that everyone has managed safe drinking water. And so it means located on the premises, available when needed, free from contamination. So 71% do have that. It also means, it doesn't mean, actually, so what about the other 29%? Well, some of them, it's not as bad as we think, but 2 billion people on the planet are drinking water that's contaminated by feces. That's not acceptable. Not acceptable by any standards. And a lot of people, it's a 30-minute walk to get to the water. We all worry about, oh, did I get a good parking spot to go into the gym to do my workout? These people are walking just to get their water. Yeah. Anyway, that was in 2015. Coronavirus, we haven't really worried about safe drinking water. I can tell you stories, but not on this video. So the dew bank. So what I want you to find is some innovation that is trying to solve this. And again, you're going to look at the good and the bad. Some of the innovations are really cool, but they might not be actually practical. But the dew bank bottle is based off of this beetle who sticks its rear end into the air and the water rolls off of it. And so there's a picture of the dew bank and they put it out. You can see it's out there. It's like in Major's backyard in Egypt. And it collects the moisture from the night air. And then they have it in the morning to drink. All right. Biomimicry interfaces. So these are actually synthetic, but the top is hydrophilic, the bottom is hydrophobic. So the water droplets detach when they come down. And so there's all different designs, but you can Google that. It's used as materials for houses, and then channels drop it into the drinking tank of the water. And so in 24 hours, you can get 10 liters. These are other ones that are screens that catch the fog, which is pretty cool. So if you want, again, for this lab, you're going to write 1 page about an innovation for either cleaning up the water or trying to get clean water or drinkable water to everyone. And so this is spider webs. So again, mimicry. So silk fibers that are used to catch the fog. And then it goes into these tanks that have the water for the people. That was actually a popular topic last term. A lot of people wrote about that. Desalination, right? So ocean water has saline. So nature actually has 2 ways to deal with this. One is mangroves, which unfortunately are being deforested, but mangroves have a natural filtration to get the salt out. And so they're looking at the membranes. So the cellular membranes are unique, and it is something they're trying to mimic. I don't know much about it, but that'd be a cool topic. And the picture of the seagulls is on there because seagulls have a gland that actually removes the salt from the water. And so they can actually drink the salt water. You and I could not. It would actually dehydrate us. And then we die. So, all right. Sorry, that was also there's these big, this is a real picture, beautiful art, right? But it's a desalination. So it is using solar power to work. So desalination requires a lot of energy, but that would be a cool topic. And then if you like it, then you can expand it into right? You're starting your initial page into the 3, 4, 5 page paper, and you'll do a presentation in the next 2 weeks. So camels. So again, Major, I must have known when I made this slideshow 5 years ago, you'd be in my class. A camel breathes out moisture. Its nostrils are actually designed to breathe back in the water, to capture the water. It also captures the water in the night air. And so this is the Sierra Forest Project, and they're cultivating the desert land to grow crops. And so there are ways to capture the moisture in the air. So the water is there, it's in the air, it's there for us. And we now have the technologies and the know-how of how to do it. And so this is smack in the middle of the Sierra Desert somewhere, that they're growing these greenhouses and growing crops, which is pretty amazing. Not having to desalinate, using the water that's in the air. So if you could ask nature, what would you ask? Well, nature is, right, the vibes. They intrinsically, they have that innate knowledge of knowing when water is clean and is not clean. They also know how to self-regulate. We, for some reason, with our free will, have chosen to remove ourselves from that cycle. And it's just when we suddenly realize, like, we're kind of in that heart attack moment that we have to do something. So these are not water innovations, but for your topic paper, you could pick one of these. These are some that nobody picked, but if you're looking for one, they have to do with air. So there are different types of paints. These are paints that absorb the heat, so solar powering the house with the paint, or there are other ones that actually absorb CO2, so they're helping to clean up the issues of CO2. This is actually volcanic soil. That volcanic soil actually absorbs more CO2 than other soils, and also is more nutrient dense and naturally protects against pests and diseases. A lot of you talked about the green roofs and the vertical gardens. So this is a green roof. So rather than generating energy, it's helping to absorb the CO2. And then it's a really nice place for the people who work there or live there to go up and just meditate, right? Solar powered transportation. These are people who made bamboo. Bamboo, if you live in most of the world, bamboo just grows like a weed, and it's amazing and beautiful and really strong fibers. And so they made these reusable and decomposable plates and stuff out of that. There's a whole thing with straws and stuff and using corn. I like the bamboo ones. I think it's the green. There's also a bicycle. So you can do something as simple and elegant as a bicycle, and new technology for so everyone can get around on bicycles. Yeah. Or just eating like Mother Nature does. Going to the farmer's market. This is there. That was actually that previous one. Yeah, there's that's a sketch for a potential future motorcycle that is solar powered. And also, I want to put it out there, and this was inspired by Damon, that he did one on bio-inspiration. So you could just find out one way that we're mimicking nature. So from the gecko's foot for surfaces, to tilapia skin for burn victims, to eating like Mother Nature, using feathers for a new type of plastic that's biodegradable. And so the San Diego Zoo predicts by 2025, this will be one of our biggest generators for the economy, if not the biggest. And this is on there because the spider web, again, it's better than Kevlar. So they're actually making new suits of armor from it. But you could also, I've had students in the past who did something from the Marvel comics or DC comics. They actually have some really cool innovations in there. And so that is always possible. And they had a lot of fun with it. So all right, and this was one I mentioned in class. So wind turbines have actually been designed to mimic the whale. And so the turbine blades are actually, right, more efficient because of how the whale's fin. They said, why is the whale's fin like that? And it turns out it has an efficiency for when they're leaping. So back to our experiment. So you guys have some post-lab questions. You're going to write a 1-page about some kind of water-based innovation. And then you're doing an experiment. So your experiment is you're going to have water, and then you're going to pick a whole bunch of different liquids, I give you categories like an alcohol or hand sanitizer. An acid would be vinegar or lemon juice. Oil, so most people have some kind of oil in their house, unfortunately. Something from the bathroom, so that could be fingernail polish remover or Drano. A drinkable, and you're going to see if it mixes with water. So is it polar or non-polar? Is it hydrophilic or hydrophobic? And then you're going to try the same with some solids. So you're going to mix some solids with each one of these. And so there's some vague instructions for you to play with. And reminder, safety first. So if you have goggles, you should always wear goggles when you're experimenting. And also a reminder, you need to take a picture. Well, also a reminder, you have to take good notes. So you have a page you have to fill out. Probably take a half hour. It's supposed to be 2-hour labs. So you guys be thankful you're not having to sit there and record temperatures for 2 hours and then clean up that mess. There's also some calculations you get to do, not from your experiment, but some calculations for the post lab. I am thinking, oh, picture. You have to include a picture of yourself experimenting, gazing in amazement at what mixes and what doesn't. All right. And you're going to clean up your mess. So have fun and good day.